Morning. Good morning. All right, you're welcome to our today's lecture. Remember, yesterday we were supposed to have pharmaceutical calculation, right? But we had AUM, so I said and I switched. So today we take a look at pharmaceutical calculation. That place you're passing, stop it. It will affect. Can't you take this way? Please, let's stop. Okay. We are live, please. Let's stop as soon as any shake, anything, any contact there. We put the camera down, okay? All right. So let's today we'll take a look at pharmaceutical calculations. BT 253. Okay. Okay. In our last lecture, we concluded with numbers and numerals, right? So this is also an extension of what? Numbers. It's numbers that gave rise to numerals, right? The same number gave rise to what? Enumeration and what? Notation. Because all of them gears towards trying to represent number in one way or the other. Remember that number is just an idea. Be conceived. Number is an idea. So it needs to be what? Represented. So you understand and make use of it properly. Am I communicating? Remember, this is not a pure mathematics class. This is just, I just want to mention one or two things about numbers. What I told you, there are a lot of things about numbers. I just picked what we need in what we are doing here in our pharmaceutical calculation, because the course is pharmaceutical calculation and you must make use of number. It's just for you to have an idea of what number is. It's deeper than what we have explained so far. So number is very, very deep. There are a lot of things about number. So the same thing we hold here. I just want you to understand what is enumeration and notation. Now, remember, we discussed that numbers, irrespective of the race, the tribe, the language, whatever, number. If you are given three items or three objects, in our minds, what we have in our mind is what? Three. But the way we represent it may do what? Differ. That's where numeral comes in. So each, be it tribe, be it whatever, be it race or whatever, language, whatever, they have their own numerals that will help them to understand, to be able to communicate. If our own is that once I clap my hands 3 times, that is how we represent number. It becomes that for us here. When we are discussing something and what topic, maybe I want to tell you that I bought four shoes. I say shoes 4 times. You know that it's 4 shoes. Am I communicating? If it is by using tally like this, it's 5. And once we do like this, we know exactly how many. But in our minds, we have 5. It's only those that understand this that can communicate in this numeral. In this, if taking to be numeral now, in this what numeral. The same way, only those that will understand that this same 1, 2, 3, 4, 5 now is actually the same thing as 5. Am I communicating? And this 5 here is also actually the same thing as what? 5. Am I communicating? It's also the same thing as 5. Now, this is where numerals stop, and we discuss a lot of things about numerals. Now, we are not going to enumeration. So, what is enumeration? Enumeration is just counting, or you can say that enumeration is the listing of objects in order, in a particular order. It may be in increasing order, it may be in decreasing what? Order. Once you list or count in a particular order, is what? Enumeration. You are enumerating. You don't just, if you just count or list in just anyhow, in a scattered order, no particular order, you are not enumerating. Am I communicating? You are not enumerating. So once you list object or count object in a particular order, maybe from, of course, now if you want to count, okay, now if you ask now, okay, can you count 1 to 100? Then you start 97, 20, 78. Are you enumerating? No. It must be from a particular order, either 1 from the lowest, 0, 1, 2, 3, 4, or you may decide to start from, maybe if I ask you to 100, you may decide to start from 100, 99, 98, you are enumerating in a particular what? Order. And remember, you cannot enumerate if you don't understand the numeral you are working on. The building, we discuss the building block of a particular numeral. If you don't understand the building block, you not even know how to place them to be able to count in a particular what? Order. Now, of course, we know when it comes to Arabic numeral, you know the building blocks are Arabic 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, another thing then in Roman, that's not I. Who say I now? X. L. C. D. N. S. Okay, now look at it now. There is what is called, apart from knowing the building blocks, you should need to understand something. I made mention of it. Values of this building block. Their values are not the same thing. Depending, if you look at it, what you are looking at now, if you look at it as 1, you are looking at what? The face value. Face value. And we have the place value. Face value, you see it as 1. But place value, how is it placed? That's when you start talking about the what? Is it in units? Is it in tens? Is it in hundreds? Now, if you see this, okay, I think it's working today. If you see this, look at this one here. See this one. If you look at it, there is 1, right? But look at it when it appears in 10, or when even it appears in. Okay, let me use 1 alone. 1 1 1 1 1 1 1 1 1 1. Look at this one. It's still 1, right? The same one. Face value, the same thing is 1. It's just 1. But place value here, this one here is not the same thing with this one. Hope you know. Yes. The value of this one here is not the same value with this one here. The value of this one here is not the same value with this one here. Have you now seen that if you want to count, enumerate, you must know about place value. Now let us now count. If you count 0 to, okay, now here, now what is the place value of this one here? Unit, right?
Yes.
What of this one?
Yes.
Right? 1 plus 1 times what? 10. Are you aware?
No.
You're not aware? Okay. Here, 1 plus 1 times 10 raised to the power. Okay, let me open it up so you will understand. Let me do it longitudinal. So you have 1, here is 1 times 10 raised to the power what? 1, 2, right? True of us? True. Good. Here now, plus 1 times 3 raised to the power what? 1. Plus 1 times 3 raised to the power what? 0, right? Good. If you bring it down now, this one will give you what? 100 plus what?
10.
Plus what? 10 plus what? 1. Add it up.
1.
So the place value of this one here is what? 100, right? The one here is what? The one here is what? Units. Now, we remember all this one. Now, let us now enumerate now from 1 to 100. Let's see. Here is 0, right? Here is 1. Of course, you know that 0 is in counting. Which of the numbers do we take as counting numbers? Is it natural number? Is it whole numbers? They forgot. Which one? So natural number starts from where? Here, this is 2, right? 3, 4, 5. 1, 2, 3, 4. 5, 6, 7, 8, and what? 9. Now, this is the. I'm enumerating now. Remember, we want to enumerate. That thing you say, you just count 1, 2, 3, 4, like that. 10, 11, 12, 13. Now, look at it now. This is the base. This is the base, the building block. How do we now build? How do we now build? How do we now build? These things are unit, right? Unit, right? This is their place value. 1, 2, 3, 4, 5, 6. Their place value is this, right? Now, how do we now get this place value here at this first level is what? Units. Next one is what? 10. Okay. Let me place let me put it here. Remember, here is what? Unit. And unit is 3 raised to the power what? 0, which is 1. True of us? 3 raised to the power 0 is what? 1. So if here is, this is 3 raised to the power what? 0, which is what? 1. I would have put this here, but because of space. Hope you understand what I'm doing. So this is the first row. The building block units. Even though we know that we have, if you go, why we don't want to go to the negative part of negative side of the number line, because we are talking about counting number. It starts from 0. Those ones are not counting numbers. Hope you know. So that's why, if not, here we shall start from infinity 3 raised to the power minus 1 minus either 50, come down to 3 raised to the power minus 1. Before what? 3 raised to the power what? 0. But because we are dealing with counting numbers, we start from this units. Now, the next row should be what? 10 raised to the power what? 1. So how do we now build this row? How do we now build this row? How do we now build this row? Remember what we did when we said that 1 is certain as saying 1 times 10 raised to the power what? 2, right? Plus 1 times 10 raised to the power what? 1 plus 1 times 10 raised to the power what? 0. Here is what? 100. Here is what? 10. Here is what? Which is what? 111, right? Remember? Now, can we do a thing like that here to generate what should be here? So how do you go about it? Any idea? No. Contribute. Any idea? I've laid the foundation. So let me see what you understood from what I've been saying since. Is what? Is what? 0. Okay, start from here. Is what? Is what? 10. Good. Let me put 10 here. Everything here will give you 0, 0. So let's forget about this. Let me put 10 here. Here, uncle. 2 times 10 to the power 1 is what? Is what now? The confidence what you're saying. You're saying 20 as if you're not sure. Here is what? 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 This one, this one. 2. Here is what? Here is what? Is it 200? Good. Here is what? 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 3 for 3 should come, right? Here is what? 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 And 9,000. Now look at the big question. We have succeeded in building also something, but what happens to the number between this 10 and 20? How do we get them? That's another big question now. We are enumerating, hope you know, we are enumerating. So how do you now get numbers between 10? I'm telling you how the numbers where the count was built. The face value is 119. Remember, there's nothing. Can you see anything that is not, that doesn't fall between 0 and 9 here? That's why they are building what? Block. How do we now, what is between this and this? How do we now generate what should be between this and this? 11, 12, 13, 14. How do we now generate it? And I want somebody that thinks. I want somebody that thinks to tell me. I said nothing. So that thing, that thing inside your skull is what? I said nothing. She said we should subtract 10 from what? 20. Will it work? Okay, yes, thank you. What do you think? I'm sorry.
Do something like 1 times.
Okay, come. Okay. So let's see what we can do about it. Please stop, please.
This one now is 10 plus 1 is 11. But the numbers are still here. And it's 10 plus 1 plus 2.
Sorry, say it again. Okay, you can see the board because of this thing. Okay. You can see it now. Yes. All right. So someone said no. Okay, okay, you continue the same that happened here in between this and this. That same process. Okay, you don't run, stay. You can go and sit down. Yes. All right, okay. She said that same process that led to generating this thing here, we should also continue the same process to fill up this place. Let's see whether it is true. I'll be adding it up to what? 10. When we get to 20, we'll repeat the process and add it to 20. Let's see whether it will work. So let's go. Remember, we'll repeat the process and add it to what? 10. To build from 10 to 20. Let's see whether it's true. So the process here is what? That this 10 here plus 1 times 3 is 0, which is what? 1. You add it to 10 to give you what? 11. Now this 10 here again, right? Plus what? 2 times 3 is 0. It will give you what? 2. You add it to that 10. It will give you what? 12. Then 3 times 3 is this 0. It will give you what? 3. Add it to this 10. It will give you 13. Then 4 times 3 to 0. It will give you what? 4. Are you following? Yes. Good. You add it to this 10. It will give you what? 14. 5 times 3 to 0 is what? 5. You add it to what? 10. It will give you what? 15. 6 times 10 to 0. It will give you what? 6. Add it to 10. It will give you what? 16. 7 times 10 to 0 is what? 7. Right? Plus 10, it will give you what? 17. 8 times 10 to 0, it will give you what? 8. Plus 10, it will give you what? 18. 9 times 10 to 0 is 9. Plus 10, it will give you what? 19. You now enter 20. I need 20 now. You do the same thing again. 1 times 10 to 0 it is what? 1. Plus 20, 21. This first row is clear, right? Let's see whether it will work in the third row. This first row is clear. You can complete it, right? Good. Let's see whether it will work in the third row, which is 3 to the power 1. Which is what? Yes, 3 to the power 1. Remember, we want to fill up this one, right? This is what we want to fill up. Which one are we going to use to fill this one? Is it this one or this one? Both of them. Let's see whether it's true. All right, let's go. This 100, right? Good. Okay, so which one should go first? If it's both of them. Okay, if you do 100 is here, right? Now 1 times 10 to the power 0 is what? 1, right? Plus 100 is what? 101. 2 times 10 to the power 0 is what? 2. Plus 100 is what? 102. 3 times 10 to the power 0 is what? 3. Plus 100 is what? 103. Then let's move to 9. Okay? This one is clear, right? Now 9 times 10 to the power 0 is what? 9. Plus 100 is what? 109. We now come down here. 10. Is it correct? Is it 10 times what? 10 times what? Is what? 10. Is it here or there? Okay. 10 times 10 is what? 0. 10 times 10 plus 0 is what? 10 plus 100. 110.
You want to do 111 again? Add that one.
Yes. This, remember, we are building these numbers with a count. That's what you are building. Remember, we want to build from 100. It's a large list of numbers. From 100 to 200 is a very large list of numbers. True of us? Yes. Then talk of from 1,000 to 2,000. But this is the system. You keep building it until you fill it up. Does it make sense? Ask a question.
But you 1,000, this system is not 1.
Okay, let's check. This 1,000, right? Okay. If this is 1,000, the first thing is 1,001. 1,001 should come first, right? It's not 1,001. It's not 1,001. It's not 1,010. It's not 1,001 that should come first. So here it becomes, you go back again. 1 times 3.0 is what? 1 plus 1,000. You have this. Then 2 times 3.0 is what? Plus 1,000 is what? Now, if you want to move from this to 10, you do 10 times 3.0 is what? Calm down. I'm coming. This will continue until you get to. Remember. So you do 10 times 0 is what? 10. Plus 1,000 is what?
1010.
Now, if you want 1 for the next thing that should be is 1. So what do? Here is what? You do what? What do you determine? Is what? Add it where? Add it here. Here. If you do something came up now, we need to open up. That's why I asked this question. Remember, we are doing, we want to generate 1,011. So what do we do? Do we add it? How do we add? Remember here, we simply did 10 times 3.0 to give you what? 10. We add it to 1,000, right? Remember? To get this thing. So what do? Do we still go back, since we have reached 10 here? Do we still go back to that 1,000? Or do we still start adding on this 10? I like this. This class is becoming interesting. Okay, now how do we now get 14? Okay, you add 10 plus 14 again. Okay. Now, how do you now get to? Okay, that means you can do that until you get to 1019, right? Now, how do you not generate 1020? 20 times what? 0 is what? 1. Wow. So how do we now get? You can do 100 times 3.0. Do you know what? See, everything you are combining. You don't even need to do anything with all this. Remember, this was built from this. You can work with this face row and get what you're looking for. You can work with this face row and get any number you're looking for. Remember, this is the building block. You can build anything up on top of this thing and get any number you're looking for. So this is what elimination is all about. At least to this, it's deeper than this. So if we did why I'm trying to cut some things is that this is not a pure mathematics class. If you have to discuss enumeration, a lot of things, you start going to set other things. I don't want to go into that. It's not what we are here for. I just pick the ones for I want to understand that these numbers you have been counting from primary school is built upon these 9 digits. Okay? We call this what? Digits. We call them what? Digits. Okay? So now this, how many digits does this number have? Digit, right? Good. You know that number, yes, we agree that numerals are used to represent what? Numbers. Now, if you now write that numerals now, those figures that make up that numbers represented by that numerals, each of these figures are called what? Digits. Am I communicating? So some numbers that represented by a numeral can be 1 digit. Numeral, it can be 2 what? Digits. It can be 3 what? Digits. It can be 4 what? Digits, depending. Am I communicating? So now, with this now, I will stop here in enumeration. I will stop here. Even if it has nothing to do with numbers, even list of things, you can enumerate things. That in examination, if you're asked to enumerate, please follow a particular order. If you're asked to enumerate, if your question says enumerate, it can be order of importance. Am I communicating? It can be order of importance. It can be order of it can be order of maybe if the question has to do with discovery, it may be order of maybe age, from the oldest to the what, or from the newest to the what, or from the oldest to the what. You must follow a particular. That's the meaning of enumeration. There are people that they will ask question to enumerate, they just be writing anyhow. Try to understand the question, then enumerate it in right order. There must be an order. Maybe the order of their size, the sizes, from the smallest to the what? Largest. Am I communicating? So that's what enumeration is all about. So here now, remember we started from 0, right? To whatever infinity. Positive what? Infinity. So this is how the business is built up. So this is, I will stop here on this. Now let me go to, unless you have any question to ask. If not, I'll move to what? Notation. I'll move to what? Notation. So with what we discussed now, you can even build up to 2,000 on your own. True of us, you can do that. This duster is not helping me. Look as if it's even dirtying the board. Okay, I check this one. I take. No. Oh. Okay, so what is now notation? What is now notation? Remember we said that numerals are used to represent what? Numbers. Am I communicating? Now, notation talks about different ways these numbers are what? Represented. Okay? Notation talks about what? Different ways the numbers are what? Please be careful. If you're not careful, you may when it comes to enumeration, numerals and notations, you may get confused. You may think that they have the same word, that they have the same definition. Yes, numerals represent numbers. Yes, but notation talks about what? Different ways you can now represent these numbers. There are different notations. But I will pick notation that concerns us in what we are doing in FarmCalc. In FarmCalc, yes. That's the notation that there are many of them. Now, the first one I want to take a look at is what? Fractions. Percentage. Fractional notation. This one concerns us in what we are doing in FarmCalc, okay? So this will take us to the topic fraction. Where am I writing nation? Percentage is also there. Then the other one that concerns us, we use in our farm calc is exponential notation or scientific words notation, or the one you generally call standard form, okay? Or standard form. So you can also say that notations are different forms in which numbers words are represented or appear, okay? Represented or appear. So now, so standard words, notation or form, anyone you call it is okay. So we have exponential, some you say anytime you see exponential, scientific notation or standard notation, that's the same thing. Okay, good. Then this is basically what we need in our farm calc. These are the basic notations we need. So that's why I want us to look at them. So let's start with fraction. So this will take us to the topic what? Let's mark for another fraction. It shock you. Okay, it's okay. You are here to unlearn, then learn. It shock you. Fractional notation. Fractions are, we have two types of fractions. We have the common fraction and decimal fraction. We have common fractions and decimal fractions. So the decimals you are talking about is under what? Decimal what? Fractions. Okay? So it's under fractions. Let me be sure there's nothing else I am missing. These are basically what we need. Now let's go to fractions. I've listed the three notations we are going to discuss under notation. So let's look at fractions. You can call it fractional notation or simply what? Fractions. Good. So, fractions. Remember when we were discussing numbers? Rational numbers. I told you that rational numbers are fractions. So, what is a fraction? Adam, what's a fraction? So define fraction for me. Define fraction for me or something. I agree with you. It's an anonym. Define fraction. Okay. You say that numbers, fractions are rational numbers. Oh yeah, define rational numbers. You can define that. That's what fraction is. Define it. Or you can simply say a fraction is an expression in form of A over B, where A and B are what? Integers. A can be 0, but B cannot be what? 0. Okay? So fraction is a So now let me explain something. Common fraction, decimal what? Fraction. Okay, look at these two things now. I don't know what I should do with this thing. Why I bring this thing here? It's better share, right? So it doesn't block it. Right? It's better, right? I think it's better. It's such gonna help me, please. Let's get this table and fix it. Fast, 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 fast. Fast, fast, fast. Ha. Biko, go and sit down, Biko. Look at this muscular human being here. You're like we can't you see now? Come. I say, sit down. Oh yeah. I think this one is better, right? It's better. It's better. It's better. All right, so common fraction, decimal fraction. I told you that fractions. But when we discuss ratio, you understand. Of course, ratio comes from where? Rational number come from where? What? Ratio. Remember, we have a topic. Our fourth topic is ratio and proportion. Ratio, proportion, and variation. When we get there, you now realize that this fraction, this A is to B, is same thing as what? Okay. So this is where this. Of course, this is basically fraction. This is fraction, right? Common fraction, right? Good. But you may have remember what we discussed in numbers. Remember, common fraction. You may see two numbers. You may see something an expression like this. Two over 4. Or even 3/7, or even 20/7. Wonderful. This is what we call common fraction. Okay, this is the one that is actually in this form. It's called common fraction. But decimal fraction has decimal points. Okay, decimal fraction has what? Decimal points. I want to point out. Remember when we discuss rational numbers, I told you that you may have a number like this. 3/7. You may not know whether it is rational number or not until you move it from common fraction to what? Decimal fraction. If you move it from common fraction to decimal fraction, you can now test to know if it is what actually a rational number. Remind us, how do you now test to know whether it's a rational number? We discussed this, right? So how do we test to know if it's a rational number? I said that if a number appears in this form, common fraction, you don't jump and say whether it's a rational number or not. If you want to test if it's a rational number, move it to decimal fraction. Remember I told you that decimal fraction has decimal point, okay? Move it to decimal fraction. Then if you move it to decimal fraction, you can now test if it is actually a rational number. So how do we now test if it's a rational number or not? If it's what? If it's what? Recurring. Is that the right word to use? No. If it has what? No. Terminating the decimal is rational. So, how do you know? It can also be recurring and be rational. Huh? No, you are missing something. What did I say about this? That will make you know whether this thing now is actually a rational number. It must have a pattern. If it doesn't have a pattern, yes, it may be recurring, wonderful, but that recurring, does it have a pattern? Okay. If you have 2, after some time 2 will occur again. Didn't 2 repeat itself again somewhere? But does it have a pattern?
No, sir.
So if it has a pattern, if you divide it and it has a pattern, then it is a rational number. But if it doesn't have a pattern, it's not a rational number. Divide 3 over 7. Does it have a pattern? Do it. Okay, call it 4, 2, 8,
5, 7, 1.
4.
2, 8, 5, 7, 1.
So it's a rational number. It has a what? But so it's not every number that has decimal point is a rational what? Number. So if it's not a rational number, is it a fraction? Is it a fraction? Not every number that has a decimal point is a fraction. Though. That's what I'm making here now. The point I'm making here is that not every number that has a decimal point is a fraction. Is pi a fraction?
No.
Pi is a fraction. Pi has no pattern. Is root 3, is sod a fraction?
No.
Sod has decimal point, but it is not a fraction because it has no pattern. After the decimal point, the digit that follows are scattered. Look at this pattern. After this 7, after 1, 4 came back again in that pattern, and it is after every 1, 2, 3, 4, 5, 6 digits, it will start again. That's the pattern. So it's a fraction. And I don't know if I'm communicating. Good. So be careful. Be careful when we are. So this is actually, that's why, listen carefully, that's why you call it decimal fraction. Not just decimal number. Between decimal and the decimal fraction. Not all numbers that have decimal point are fraction. That's why we call it decimal fraction. Common fraction is in this form. Am I communicating? So any number in this form, before you can say, I can give you a number like this and say to check whether is this a fraction, and one year that's not a fraction. You must test it yourself to be sure it's a fraction. So after this class, try as much as you can generate different numbers and keep testing. All of them may be fractional. I can't say, but I've already told you that if you want to test, first move it from common fraction to what? Decimal fraction. Then you will check the pattern. If it has a pattern, it's a fraction, it's a rational number. But if you don't have a pattern, forget it. It's not a fraction. It's not a rational number. It's an irrational number. Any question? Ask.
So this recurring number we are talking about, the recurring fraction,
Okay, ask.
we have both single and non-single.
Yeah.
How do I differentiate two single?
No, you can have. Okay, you divide 1 over 3. 0.3333 is single. Is that same 3? But this one is not single. After 6 digits, it will come back again. She's taking us back to what we have done. No problem. I will allow you, even though you messed up. But I will allow you. So this is 1 over 2. Is what? Is top at this point. 6 over 10 is what? Is stop here. It's terminating. It's terminating too. Yes. It's stop now, but this one has no ending. It has no ending. It doesn't end. It's you. If the size of the calculator, can you remember we divided from here to the board? Did it end? If the size of the calculator is from here to here, it will keep going. From here to London, it will go in. It can never end. It will just, after 4 digits, After 6 digits, it will come back to 1. Once you get to 7, it will repeat again to 1. Once you get to 7, it will come back. So once you get to 1, it will fall to start again. This is what you keep doing, unending. That's why it's a continuous number. It doesn't end. It doesn't end. But because of the pattern it takes, is a rational number. But if it's scattered, no pattern, anything comes, it's a rational number. Am I communicating? So, common fraction, decimal fraction. These are the two groups of fraction we have. So, under common fraction now, the one we state like this, you have many of them, right? This is where you start having your proper fractions, improper fraction, and your mixed what? Fraction. Okay? What gives rise to mixed is improper fraction that gives rise to mixed fraction. Please, if give you question and you solve and leave your answer in improper fraction, you have failed that question though. You must move it to what? Mixed fraction. Let's assume you are solving. I gave you a question, you solve and you got 20/8, and you stop here. So it's me that will complete it for you, right? No. Move it to what? Mixed fraction. You got what? What will it be? Huh? Is that what? Is that what? Say it again. 12. 12 whole number. What? Is it correct? 2 times 8 times 2 is what? Plus 4 is correct. Is it clear? Please move it to mixed fraction for me. Yeah, you can. You can. Okay. They are fraction. God bless you. How fraction? Do you know the meaning of fraction? I just told you. I just used the division of rational numbers. If you go down to actually what fraction actually means, that question will not. I believe you know fraction. I can't come here and start defining fraction. Yeah, primary school fraction. You know now, fraction is part of a whole. True of us, part of a whole. I can't come here and start drawing orange for you on the board and divide it into 4 and say and shade one part for you. And to me, it's somehow. That's why I went straight to what you have not heard or what is confusing about the issue of rational being expressing in this and this, where one is the way the numerator and the denominator are what integers, but the numerator can be what 0, but the denominator cannot be what 0. And I didn't want to come and start asking you again which one is numerator. It's somehow to me. That's why I just moved straight to what you don't understand. But if you want me to go that lane, I will throw that lane. I'm just taking time. Sorry. I would have started from primary school. I'll do orange, divide it into 4. From there, numerator, the denominator. This one is the numerator. The one the denominator, and this is the fractional line. Then okay, so someone said that it's not be bad. Okay, let me do it. So you not divide it. So this is part of it, right? This is you already this one into 4. Why are you laughing now? Okay, you don't share this part. So this part represents, there are 4 parts here, right? 1, 2, 3, 4. These 4 form the what? Denominator. The shaded part is 1. So this is 1/4. So this is the common fraction. Do you know why common fraction? Do you know why irrational numbers are not fraction? You cannot represent them in this form. But 3/7 can be represented in this. You can divide that into 7. Take 3. But if you cannot, if you don't have a pattern, you can never do anything like this with such number. Am I communicating? That's the problem. That's the problem. But what I want you to test, I want you to generate as many. I want you to generate as many numbers like this to see whether if there's actually any number in this form that will not be what? Rational. I don't think so. Once you can put it in this form, I don't think so. I've not seen. I've never seen. Once it can be in this form, this thing has made it fraction. But where the issue comes is those in decimal point, those that have decimal points, not all of them are what? Fraction. Please note that this is where the issue lies. I've never seen a number in this form that if you divide it, you know have a pattern. I've not seen before. I'm not saying that it does not exist, but me, I've not seen. Most of the numbers are divided always give me a pattern. But you can you can check maybe in a next class or any time if you can work with any number possible and check whether you can get anyone with that pattern. Then let me know. Any question? Either terminating or pattern. You want you raise your hand. Okay, you okay now? Good. Now, it is rational. A whole number 20 over 1 is what? So it's rational number. Remember, of course it's true. What did I even say? Once it's in this form, it's a rational number. Remember the division. It says can be expressed as what? A over B. Where the A and B are what? Integers. A can be 0. B cannot be 0. It's rational. So any number in this form is what? Rational. So let us not waste our time. But you can tell, I don't believe in what they told me. Sorry, that's how I studied. I don't believe in what they told me. Because if you keep believing in if our scientists believe wholeheartedly in what they told them, I don't think there will be what discoveries and modifications of rules and law, rules and theories. Okay, that John Dalton's atomic theory. If those scientists just believe everything they do without working further, I don't think the theory would have been modified. And the modification of that theory led to a lot of beautiful things in the field of chemistry. True of us. So I don't believe. Even though yes, I'll find it, but I want you to on your own. That's what if you work on 500 numbers, you work on 500 numbers. All the class work on 500 numbers, different numbers. We would have worked on almost 5,000 numbers to check whether this thing is true or not. So if it's not true, we raise alarm. Disturb the world of mathematics. Let's look at this thing again. Let's revisit the definition of what? Rational numbers. There's something we noticed we need to work on. Any question? Ask.
Rational numbers, but they are ratios.
What?
Rational numbers are very ratios.
Yes.
They are ratios.
Yeah.
And you said that ratios and you said that ratios they have patterns. They actually
Majonia. Majuzari anonne. Ne doziam.
That all number having A over B, they are rational. That means both the ones having patterns and the ones that does not have patterns, they are ratios. But rational numbers are ratios. And you say that all numbers having A over B are ratios. And you also
I never, and I can never in this my life say that all numbers.
as in A over
I can never do that in my life. I said that rational numbers are numbers that can be expressed in form A over B, where A and B are integers. Mark my words, integers. I didn't say all numbers. So continue. Let me know where you're going to.
Okay. Let me, for example, now 2 over 4 now. It's in the form A over B.
And 2 is integer. Two is an integer, four is an integer, so it's rational.
So it's a rational number,
Yeah.
just a ratio.
Yeah, yes.
Then which one in the total that is in bracket? Because 2 over 4 is 0.5. And
I said terminating one is rational. Okay.
Not terminating.
It's terminating the one I carry.
It's only irrational.
Okay, pass or where the issue comes is continuous numbers. That way where is having such issues. When it's continuous, you watch it. See whether that continuous number has a pattern.
Okay, that means irrational numbers cannot be.
No.
Okay, it's only.
Ask.
So this thing that you said discrete numbers that they stop at numbers.
Okay.
Can whole numbers also be discrete?
Yes, now they are.
Then something like 1.5 is also discrete.
It is. Can't you count one and get one half and count it? Even though yes, it's not natural counting, but we can do that. True of us. Just know that discrete stop at the point. Come in.
Then what about
Okay.
what about 1.128 like
1.128.
yes, after the plot is now
See, is there anyone like 1.128? Without being an approximation. Wait, I ask a question. Is there a number like 1.2128 without being an approximation? It's a question. I didn't say there is no. 1.128 without being an approximation. Is 1.128 does it stop here, or was it approximated to this?
I'm just giving the example of the number that ends at 3.
You don't understand my question. I understand what they say. This is easy, but was it approximated to this?
No. So not there. That was where it stopped.
Such this number exists actually? No, you don't understand my question. Is it a product of an approximation? Or does it exist like this? Like 0.125 is not approximation. Is it? No, it's not. This number, does it actually exist, or is it an approximation? So it's not a discrete number now. It's discrete. You can, if you express this now, bam, you get it. You can, if you express this now, you get 1 over what? 1 over what?
1 over 8.
This 1 over 8. This 1 over 8 is not good. If you divide it, it gives you this spam answer like this. But is there any fraction you divide, you get 1.128 just like that? No. Unless you are doing 1.121128 over 1,000 over what? 1,000, right? Yes. You get what? 1.128. Remember, this thing is just, hoping that this water is just place value. You just shifted the decimal points. Am I completing? You just shifted the decimal points. You just want that. You just shift. I mean, when you have, that this thing is place value stuff. You just shifted the decimal point from here to here. Decimal movements. I mean, when you have, forget about it, when you have number like this, let's assume in this form 24 over whatever, and still get it 1.8 dots. You can configure anything. You can configure 1273 and divide it by 1,000. Look at this 1273 on its own. It's a discrete number. Am I computing? You just move the decimal point from here to here to here to here.
So these things.
and it becomes 1.2 times 3 to the power what? Minus 3, right? I asked you a question which she could not answer. I said, this thing you did, is it a product of approximation? Or you divided something, bam, and get an answer? That's where I'm going to.
Yes, sir. Yeah.
Do you know that you can be okay now let's look at this number now. Let's look at it. Divide 1/3 now. Naturally, you get what? Right? Right? Good. You may decide to stop at 0.333. Three of us, on your own, you may decide to stop here. And you go and start, and maybe you now say, okay, 0.33333, and you now come and say, you stop here on your own. It is now a discrete number. But actually, if you divide 333, is 333 not is it discrete or continuous? 333 on its own, 333. You can vary by what? 10,000 or 1,000, and get what? But this is what you got from here. That's why I told you this place. This is just talking about. This is just about the decimal place of the decimal point. Am I communicating? Which you will not use it to actually test. But this 1/3, does it make this now a discrete number? But you did 1/3 and got 0.33, and on your own you chop off this place and multiply it by 1,000 and tell me that is what? It is number. No, now. This is what you just want to do. 1/3 is not decision. So this thing is not what you can actually use to work on. You are just moving the decimal point up and down. Simple. That's why I ask you, is there any normal, not forget about the 1000 this thing. I mean, is there any number you can normal this thing and you get?
Yes, sir. Yes.
Without playing around?
Yes, sir.
What number is that? 141 over what?
125.
Are you again? Dot.
Yes.
Not approximation.
Yes, sir.
That's because I ask her now. See, I just went straight to the rule. I asked a simple question. Is there any number you can work like that and give you? Is it a product? That was my exact question. Is it a product of approximation? You see,
No, I said no. That is not that.
once again, so I give a opportunity to give me such number. You not give me. All right, so now this first time. Is that what?
847.
Ada, you took us back. Oh. Hope you know. Are you aware? Someone should not miss class and be taking us back. I won't accept it again. Now, hello, are we together?
Yes, sir.
Now, so common fraction. Of course, you don't have to be told again now. Good. Now, the question now is this. There are something I want to talk about in common fraction. Under the common fraction, of course, you know that in a proper fraction, the numerator is less than what? For what? proper fraction. For improper fraction, numerator is what? True or false? Good. So remember, you don't leave your answer for me in this form. Try to bring it down to what? Mixed fraction. Don't do that. Okay. Now, and there's something I want to talk about under this common fraction: equivalent fraction. Equivalent what? Equivalent fractions. Equivalent what? Fraction. What are equivalent fractions? Equivalent fractions. Equivalent fractions are two or more fractions that have the same value. Equivalent fractions are one or more fractions, two or more fractions that have the same value irrespective of the magnitude of their numerators and the denominators. Equivalent fractions are two or more fractions that have the same value irrespective of the magnitude of their numerators and their denominators. So irrespective of their magnitude, they have the same value. So if you see any two fractions that have the same value, irrespective of the magnitude of the numerator, they are equivalent fractions. Let me give an example. Let me give an example. You have something like this. Okay, continue. Put down something so that I'll go straight to equivalent fractions of equivalent fractions of a fraction. Equivalent fractions of a given fraction. Equivalent fractions of a given fraction can be generated. Equivalent fractions of a given fraction can be generated by multiplying or dividing its numerator and the denominator by the same number. Equivalent fraction of a given fraction can be generated by multiplying or dividing its numerator and the denominator by the same number. Okay, look at this thing. Let's start from half. This is half. What is the value of this thing? 0. What? If you want to know the value, just move it to from common to what? Decimal fraction. So when I say the value, I want to move it to decimal to what? Common fraction. So from common to what? Simple. Just simply divide the numerator by the what? So the value is what? Now remember what I said on how to generate equivalent fraction. By multiplying or dividing the numerator and the denominator of a fraction by the same number. Now we can choose any number of our choice. You can choose any number of your choice. I can choose 10. I can choose any number. But the point that you must do the operation you do here to this numerator and on this what? Denominator. Before you can generate an equivalent fraction. Let's go. Let me choose 3. Let me just choose 3. You can choose a number. You can choose 1 million. But let me just choose what? 3. So 1 times 3 is what? 2 times 3 is what? 6 is an equivalent fraction of 1 over 2. What is the value of 3 over 6? 0. What? They are equivalent fraction. They are equal. Is it clear? I can decide to multiply with any other number I like. Multiply by 4. 3 times 4 is what? 6 times 4 is what? 12 divided by 24 is what? They are equivalent fractions. Even though the magnitude of their numerator and the denominator are not the same thing. Are they, do they have the same numerator and numerator?
Yes, sir.
An array says fraction can be list of fractions can be given to you, common fraction can be given to you like this, and ask to determine which of them are equivalent. You can be given about 20 fractions and ask you to select which of them are equivalent fraction. It's simple, just simply keep dividing, move all of them to what? Decimal fraction. Then check the ones that are equal, the equivalent. This and this are equivalent, this and this are equivalent. If all of them are equivalent, you state it that all of them are what? Equivalent. Simple. Remember we had multiplying. Alright, let's do what? Division. Alright, divide 12 by 3. 4. Divide 24 by 3. 6. Are you sure?
8.
Are you sure? It's 8. 4 divided by 8 is what?
0.5.
Are you spelling by 3 or 4?
I said divide by 3. 12 divided by 3 is what? 4. 24 divided by 3 is 8. 4 over 8, these things are equivalent fraction. Divide 4 by 8 is what? 0.5. These things are equivalent fraction. Your understanding of equivalent fraction will help you when we go into ratio and proportion. In fact, what is proportion is nothing but two equating. Proportion is just equating two equivalent fractions. You get a proportion, and that's from there you now. This is the basis for your cross multiplication. When you equate two equivalent fractions, you can now cross multiply. Let's assume 12 over 24 is equal to what? 4 over what? 8. This is the origin of cross multiplication. You can call this one x, right? You can cross multiply and find s. Find s now, you to give it 12. Just test it. Cross multiply and find s, you to give it 12. You see, right? This is the origin of what you've been doing from your primary school. Cross multiplication. It's from equivalent fraction, proportion. So don't worry, we'll go to proportion. I just mentioned it to prepare your mind. You'll get there. Now you now understand what equivalent fractions is, right? So with this, any other things that we do in common fraction is just operations in common fraction. Operations in common fraction. We will test the basic mathematical operations in common fractions. And what are those basic mathematical operations? They are addition, subtraction,
Division.
multiplication, and what? These are the basic mathematical operations, basic ones. So we carry out these things. So if you hear operations in common fraction, you simply talk about how to add common fraction, subtract fraction, multiply, and divide. You will do this one from here, not school, right? Right? So it's easy. Who doesn't know how to add fractions here? Confess. Hey, if you don't confess, questions are bakasa and everything. Okay. You don't know. Child. Okay, let's look at operations in common fractions. I wanted us to just move to decimal fraction, but no problem. Let's do it. Because we are doing maths review. We are doing what? Maths review. So let's review it. Take one. Let's review. Is the pioneer? Okay, you've seen it, right? When you were there?
Yeah.
In your first year.
Yes.
The pioneer assistant class rep. The first set. Hello, are we there? So let's look at it. Addition. Let's start from addition. Let's start from addition. Okay, but you okay. Apart from this now, another thing you should talk about is how to move conversion of common fraction to decimal fraction. It's simple. If you want to convert common fraction to decimal fraction, simply divide the numerator by the what? So divide the numerator by the what? Simple. Then please, if I ask question, I don't play with number of decimal places you leave my answer. I don't joke with it. Decimal places you leave my answer. I may ask you to convert a decimal fraction, a common fraction to decimal fraction, and I'll tell you leave your answer 2 decimal places. Then you convert and leave it in your own decimal places. You have failed that question, even though the answer is correct. Please listen to instructions. You listen to what? Instructions. I ask you to convert it to decimal and leave your answer. I may even give you by the time we do approximations and this thing rounding and all this. I may even tell you to leave it in the nearest whole number. Maybe to leave it in near in the. I can give you any instruction I want to give you. So it's not just ordinary dividing. That means you must know all those things before you can solve the question. Am I correct? So please, any question you are solving, please try to calm down and understand the question and instruction. So you don't solve a beautiful whatever and fail the answer. So please take note of that, because this is, see, it's not just about passing exam and passing. It's also training you on instructions. Not tomorrow you'll be given prescription. Once you see paracetamol, you chose a mazi. Other instruction about it. You must cool down first and look at the instructions in the prescription. Very important. If that's why I don't pardon any student that fails any instruction I give in exam. I don't joke with it, because I know. But before you pass it, you must learn how to read the instruction. If you don't understand, you may call it wickedness. No, we are training you to go and save life. If you don't know how to calm down and read instructions, you have issues. Even when you are attending to patients, you have issues. So you may just say, no. It goes beyond that. You can even make such mistake even to your own parents or your own sibling, because you don't cool down to read instruction. You go and give them nonsense, and they will take and have issues. So it's not about passing now. Hey, sir, this small thing. He solved it to, you know that he don't put it into the smart. It's not true. You were not attentive. In fact, you were not coordinated to see what. By the time you start working, those in IT I will tell you, pressure, they will line up. You will not calm down to look at the prescription and be able to do the right thing. So if you don't learn, I don't know, for my course, for you to pass it, you must learn how to. I don't just give you exam, just exam. I'll be telling you this. I test not just what you have in your head, in your brain. No, I test your ability to calm down. Sometimes I'll just put one nonsense and give you. You're able to look at it and be able to say this thing is this thing is this. Means that I'll beat my chest that you have passed my course. Anyway you are tomorrow, I'll not be afraid. That's why you see people, even after the whole thing, it's not for my course that they don't. you must not pass even my receipt exam. You must not pass it. Even the third receipt, if at all you are given the opportunity, you must not pass it until you learn how to coordinate yourself. How to coordinate yourself. The profession you are in is a noble profession. It's not just anyhow. It's not just anyhow. You must be coordinated in doing things. You can make mistakes. You may, by the time you made a mistake with your own people, you understand how painful it can be because you fail to organize yourself. Most of you are not organized. After you class another ingredient winner. So please, I'm just giving you a clue so that you will prepare yourself. You give your exam, calm down. Don't think that you have arrived. Relax. Look at it again. Examine the question again. I know what you are doing. Because what I infuse in my question are my experience. The errors people commit in dispensing. That's what I infuse in my question. Because you know that pharmacy is the last bus stop. A patient will come before going home. It's only the pharmacist, pharmacy technician working in pharmacy can correct any other error committed by other health professionals in the what hospital. So if those people that are supposed to, the final man that should look at those things again, when a doctor start telling his patient to come back after going to pharmacy, you know that people have failed. Because there are some doctors that are very careful. Maybe they have noticed that people are not serious. He will tell his patient, please, after seeing the pharmacy, do what? Come back, let me see it. Most of them are doing it because of what they have seen, how disorganized you are. Okay, sir. Okay. Good morning. I'm running up. Okay. They'll be in lab soon. Okay. I'll just run up now. All right. I don't really know. Check good. So you are supposed to be the people. You are dispensing practical lecturer. So once you are done now, you go there. Hope you're with your lab coat. No. Look at this set of. Hey, yeah, child. And it's true, Ekwesi make all these courses. It's an error on my side, sorry. Very big error on my side. Very big one, I'm wrong. Very wrong. I thought okay, you know, we're not doing handbook. Up to now? Okay. You know what? In our tomorrow, the first thing I will do. What's that? tomorrow, the next. Are we together? Tomorrow, the first thing I will do. I was thinking that you will have the handbook on a more serious note. So I just focused on what I was doing. Tomorrow, the first thing I will do is to list the courses, explain them, what they are. Sorry, I assume that you have the handbook. Everything is in handbook, but I didn't know that up to now you have not created it. So what I will do is that I will explain the courses tomorrow. Then, I will also send you their phone numbers. Remind me, please. I will send you their phone numbers so you can contact them. Okay? So that's what I'll do. The first thing once I come here, please remind me, please, sir. Please explain so that you know the handbook. Don't worry, I'll find out what happened. Don't worry, I'll find out what happened. Don't worry, I'll find out what happened. Huh? Don't worry, I'll find out today what happened. If you are focused on other things, there's a division of labor, so I wouldn't know other things going on when I'm tackling what is tackling me. We pass through a lot, and a lot pass through us. So it's not easy, but now that you have notified me, I'll find out what actually happened, why it has not been sent to you. Now, I think we'll stop here. Tomorrow tomorrow we start from our quiz tomorrow. I don't like this afternoon quiz. I want it to be in the morning. Tomorrow now. But wait too. I announced that Fridays are quiz from the beginning. So what is that, Anna? Okay. What's the issue now? Let me understand the color of your issue. Ọgbahụ na-acha ka mma kọ. Ọgbahụ na-acha ka mma. Ọgbahụ na-eti gbata mma. Where is one? Ịmara ọbịa ụnyaa. Wuri na awọta ụnyaa. Wuri na awọta. I understand. I feel your pain. No, I understand. I know where you're coming from. You need time to understand what's going on. So what do we have? So okay, if you want morning, let me see your hands up. Tomorrow morning, let me see your hands up. Tomorrow morning. If you want it afternoon, let me see your hands up. Hello, I'm giving you opportunity to choose. You know me now. If I decide now, if you like, come and write. If you like, don't write. I'm going to send you. So I say Monday. Yes. Okay. If you want to Monday, we say on Monday. Yeah, you ask down. Friday. Monday have it. Now listen. Now Monday, morning afternoon. Okay, see, Monday afternoon. Hello? Are we together? Hello? Listen carefully. What's the normal time on Mondays? Yes, sir. What's the normal time? No, I mean normal quiz time is when Mondays. Monday, eh? No, I'll do my normal class. I'll not use that one for. So Monday, listen carefully. Hello, are we together? Yes, sir. Our normal lecture holds on Monday. Monday, 3 p.m. quiz holds here. If you want to attend, if you want to write, you do what? Right. But let me make it clear to you. If you miss my quiz, I don't want to know your reason. For whatsoever reason, the reason is your business. If you miss my quiz, if the normal time for that quiz is 10 minutes, that time the time I'll give you towards the end of the semester will be 5 minutes to write it. So if you look at your priority, set your priority right. Am I communicating? Yes. If you miss my quiz, I have a reason for that. If you miss my quiz, those people that write, of course, if you miss it, the next time you write it is doing shortly before the exam. Of course, that one it has been like that. So if you miss my quiz, any of my quizzes, any of them, if you miss it, that time you don't have. If the normal time I give to people that are writing it now is 10 minutes, you have time will be half of that word, 10 minutes. So let it be in your let it be in your memory. So you don't just go and stay in your house and be drinking champagne and tell me, sir. And that is for those that actually notify me. You never expect quiz. You will not write it to. You will inform me before time. Of course, you know the process of informing me now. Of course, in case I will not come unless you are unconscious. God forbid. Okay, Kalu, Amalia Gamenka. Are we together?
Yes, sir.
See, Vera looking at me. Vera is looking so confused these days. Why? What's going on? What's that? Okay. She's still managing home and here. Okay, what is here? We have started. We are now in 2004, 2020, 2025 academic session. Understand that and be happy. All right, please go and get your lab coat and move straight to the lab. If I see you in that lab, you are hot. Go and for lab coats. Go to hostel and go for lab coat. Don't cross that lab. Don't cross that lab, please. Dress properly. Get your hair. Hope you have headgears. What's that too? What's the business? Get your lab coat. Go for lab coat. Hello, please. Nobody enters that. Listen carefully. I'm coming there. Better go to start look for who to get lab coat for. If you're with your own, you don't enter. You get your lab coats. All right. Thank you very much. See you tomorrow. God bless you.